Right? Welcome to Chemistry Simplified. So here we demystify tough topics and we make every question become simpler to you. Alright, but today's class will be on the vector resolution in physics. Yeah, you're surprised, right? No, we are going to be code missing most science subjects here for every Jambas that are writing UTM. So this place will be safe for you. So today there's going to be more of chemistry. I just want to explain the topic in physics. Vector resolution. But I don't know what you're going to get insight massively. You're going to understand how to resolve vector into single components with this. Now the reason why I brought this topic that most students used to confuse the formula when you are resolving vertically and resolving horizontally, as to know when the angle theta is to the horizontal or when the angle theta is to the vertical. That is why I am here. That is what I came to demystify. Now listen and listen good. Now when you have a force like this, now it is crystal clear that this line is vertical while this line is horizontal, right? Yeah, sure. So this and this do not need resolution. You don't have to resolve this vertically because it's vertical already. This one, we don't have to resolve this horizontally because it's horizontal already. So let's assume this is what this is force. This is another force. And don't forget that we have the vertical in our graph is always what the y-axis straight and the x-axis on the horizontal line. So we call this what Fy and we call this Fx. This is our vertical component and this is our horizontal component. The force we resolve is a force that we cannot say it is vertical, neither can we say it is horizontal. So let's for example we have a force here. There is no force in physics we call slant force. No. So this force we can't give it any name. I can't name it y, neither can I name it x. Why? It is not vertical. You can see, right? And it is not horizontal. Plain, right? Simple. Now, these are the kind of forces we resolve in physics. Now let's say the angle theta is to the horizontal. Look at the force we want to resolve. The angle theta here is making an angle with the horizontal. Now, how can we resolve the force vertically and how can we resolve the force horizontally? Now let's close the triangle here. We have something like this. Opposite sides here are equal. So this is Fy and y this will also be Fx. Now, what do we need? We want to resolve this force, this theta, and this. Now, we are now going to bring out this triangle outside. How does this triangle look like? We have something like this. I want to get that here now. This is what? Angle theta. This is the force. This is Fx, and this is Fy. Cheap, right? Yes. So if we are resolving the force vertically, so this represents our vertical component. Do you understand? Why this represents our horizontal component? So if you want to resolve this force now vertically, you have to look for what join this F and this Fy together in our trig ratio. We have so and we have ka and we have toa. I believe you remember this in your what? In your mathematics from primary school. So ka toa. So where so represent this is sin theta equal to opposite over hypotenuse. This our ka represents cos theta equal to adjacent over hypotenuse, and this our toa represent tan equal to opposite over adjacent. Now, if you have to resolve the force here now vertically, so we have to look for what joins this our F with this our Fy. Simple, right? And you told the mathematics that every side facing the angle is opposite. The longest side is hypotenuse, while the base is adjacent. Simple, right? Any side facing the angle is the opposite. The longest side is the hypotenuse, while the last side is what? Adjacent. And which side is facing the angle now? Fy. And which one is the longest side? F. So our F is opposite here, and our F is what? Hypotenuse. We have opposite and hypotenuse here, right? Easy peasy. Alright, what's the next thing we are going to do here now? Very cheap. So we are using this. So our sine theta is opposite all over hypotenuse. Now our sine of theta will now be equal to what's our opposite? Fy, hypotenuse F. So we have Fy all over F. We are resolving this force vertically. So we can multiply our Fy now be equal to F sine of theta. This will now be the vertical component. You can see that, right? Easy. So it means if our angle theta is to the horizontal and you are solving the force vertically, the formula will be what? Sine theta. If you are solving the force horizontally, you have to look for what joins this F and Fs together. And as we have explained earlier, this is hypotenuse and this is adjacent. Hypotenuse adjacent. That is what? That is cos. So we now have cos of theta to be equal to adjacent all over hypotenuse. What's our adjacent? Fs. What's our hypotenuse? F. So we have cos of theta to be equal to Fx all over F. You can see here now. So if you cross multiply, we have our Fx to be equal to F cos theta. That is what our horizontal component. Very easy, right? Yeah, sure, that's basic. That means if we are resolving the force vertically, the formula is F sin theta. If we are resolving the force horizontally, the formula is F cos theta. Provided that what? That our angle theta is to the horizontal. Please, you have to note that very, very well. So now, what if our angle theta is to the vertical? What is going to be the fate of our formula? Don't forget the formulas. You can write them down. Alright. Now, we have this same diagram here. So the same diagram, but different places where we have our theta. Our theta is earlier here. So let's imagine our angle theta is here. That means the force we have to resolve is making an angle with the vertical. So we are going to bring out this triangle. So the triangle looks like this. You have something like this and like this. So this is our Fx, this is Fy, and this is where we have our angle theta. Easy, right? So we see our soul and car and toa. Now, if we are resolving the force, this is the force. If you are resolving the force vertically, we have to look for what join this and this together. And I've told us earlier that the side facing the angle is opposite. The longest side is hypotenuse. The last side, the base, is the adjacent. Now, I want to resolve the force vertically. We are looking for what will join the three ratios that join this Fy and F together. So this is opposite. So we have opposite. This is hypotenuse and adjacent. And that's what? That's cos theta. So that means we have cos theta to be equal to adjacent all over hypotenuse. So we have our cos theta to be equal to what's our adjacent? Our adjacent is Fy and our hypotenuse is what? Is F. So we can multiply our Fy will now be equal to F cos theta. That is to the vertical component. Now you can see. Can you stop here now? Sure. That's what some students don't know. And when you do your normal formula, you calculate, you will see that your wrong answer in the option. That's how down can be so funny. You can see. So when the angle theta, don't forget, we have very short questions to solve regarding this. You can see our angle theta. When it is to the vertical horizontal, our vertical component is F sin theta when you are resolving the force. But if the angle theta is to the vertical, the formula goes back to what? F cos theta. You can see that, right? Very, very important. Note that check is the angle theta to the vertical or to the horizontal. Very, very important. Now, if you are to resolve the force horizontally, we have to look for what join this Fx and F together. This is the first we want to resolve. So what doing this and this together? This is hypotenuse and this is the opposite. That's what that is sine. So we have our sine of theta to be equal to opposite all over hypotenuse. What's our opposite? Opposite is Fs. You can see the side facing the angle. So we have our sine of theta to be equal to Fx all over F. So if you want to cross multiply, we have our Fx to be equal to F sine theta. That's what horizontal component. You can see, right? That's very cheap. So you have to look deeply to the question. So if your angle is to the vertical or if it is to the horizontal, they have just different formula. You know what? You don't just go with the only one you know. This is what we were taught. That to the vertical is F sin theta, to the horizontal is F cos theta. No, that is only when you have what the angle to the horizontal. When you have it to the vertical, it is another formula. Now let's look at this simple formula. A very tricky questions from JAM under a topic in physics, projectile. Now let's look at the topic. Let's look at the question. So the question here says, let me quickly write it up. So you have a missile projected with a velocity of 250 meters per second at an angle of theta to the vertical. If the total time of flight, of the missile is 25 seconds, the value of theta is dash. So we have our A to the 30 degree, we have B to the 60 degree, we have C to the 45 degree, and D to the 50 degree. Now let's look at this question here now. Now we have question here. Now this is projectile question. The very short question. Say a missile projected with the velocity of, we have our velocity to be projected with, that's your initial velocity u, to be 250 meters per second, and at an angle of theta, where theta is what you have to calculate. The value of theta is dash. So at an angle of theta to the vertical, if the total time of flight, our t, capital T is what? 25 seconds. And you know, as a good physics student, you just saw total time of flight. You know, the formula is what? T equal to 2u sine theta over g. Right? Simple. Your g is essentially to gravity. But you don't look at what they ask you. You are just looking for what? Value of t. Now, our time of flight is 25 equal to 2 times 250 multiplied by sine of theta all over 10. Abi? So 0 plus 0, we have what? We have 25 equal to 2 times 5 equals 50 sine of theta. What are we looking for? Theta, right? Right, let's use this page. Now, we have 25 equal to 50 sine of theta, right? So we are going to what? Divide by 50. You have your sine theta to be equal to 25 divided by 50. This is 1 over 2, which is 0.5. We have sine of theta to be equal to 0.5. So your theta will now be divided by what? By our sine. So now have at sine 0.5. And you can point that in your calculator. We have shift at sine. At rate is what? Shift sine 0.5. The final answer here, our star is giving us to be 30 degree. Final answer, right? Yeah, but if you pick this answer, that's why JAMB can be so funny. Your wrong answer will be the option. If this is your answer, when you calculate it, it's very, very wrong. How is just the idea that I explained earlier. This is actually very, very wrong. That's how jam can be so funny. And you are just working, you are sweating, free students, and when you see option A, that's it. Wow, I've got the right answer. Meanwhile, it is very, very wrong. Now look at the question. It said the amphitheater is to the vertical. You have to what? You have to look in depth. Vertical is to the vertical. If it is to the vertical, it's just like the representation of this is you just have something like it. So this side is projected with the velocity of this. Projectors follow a parabolic path, right? So this parabolic path, so it's projected with this. Your u here is what is 25. Sorry, your u is 250, right? 250. Your u is 250. But they said the amphitheater is to the vertical, not here. The amphitheater is to what is to the vertical. So if the amphitheater is to the vertical, the formula will change to resolve vertically to be what? Cos theta, not sin theta. So here now, we are going to use cos theta, not sin theta. If you use the wrong formula, you will still see that your wrong answer in the option. That's why that can be so funny. So now, if we solve the question here now, so where we have t equal to 2u, now it now be cos of theta all over g. So we now have 25 equal to 2 times 250 multiplied by cos of theta all over, our second degree is 10. So we have 50 cos theta equal to 25. We have cos theta to be equal to 1/2. So you have what? Cos, if you follow the same formula, cos 0.5, our theta will now be equal to shift cos 0.5. And if you press shift cos 0.5, the answer will be 60 degrees. This is the correct answer. Do you get it now? So that's how this topic can be so confusing and funny at the same time. Please and please, you can rewatch as many times as possible as you want. So to know the formula, and always look in total to the what, to the questions, what they ask you. That's why we see many brilliant students failing physics in JAM. Not because they are not brilliant, but it's because they are not calm to read the questions enough. So if it is to the vertical or to the horizontal. Now thank you very much. If you have gained value from what I just taught you, please like, share and subscribe, and click on that notification bell so as to get notified whenever I upload a new video. So you are also welcome to Chemistry Simplified. Here we simplify tough topics and make all questions simpler. You can message this number, it's 37735. This is the number to be added to our WhatsApp channel and Telegram group. Thank you very much and stay blessed.